Good morning. Today we are continuing with our Unit 7. We are doing CO43. I can interpret and create circle graphs. This is going to continue working with our percentages. So the first thing we need to know is, what is a circle graph? A circle graph displays data as sections of a circle. So we've talked about other kinds of graphs with the bar graphs, the line graphs. Now we're working with a circle graph. The entire circle represents all the data. So we have a circle. That's all of our data is in that one circle. Each section is labeled using the actual data or using data expressed as fractions, decimals, or percents of the sum of data. So you might have a section that has its label to it. It might be TV. Or instead of having its actual label, it might be a percentage. So you might see 20%. Or a fraction, 1/5. 20% is 1/5. Or a decimal, 0.20. Array is a part of a line that begins at a point and extends in one direction without end. So array begins and goes. An angle is a figure formed by two rays with a vertex. The vertex is where they join. So we have a ray here, and we have a ray here, and they form an angle where they meet, where they intersect. So an angle is two rays intersecting. Where they connect is called its vertex. So that's the common endpoint of the two rays that form an angle. The degrees is the unit of measure for the angles. So if we look at my circle graph that I did, we have one ray on the bottom, another ray on the top. The angle is between the two rays, and you can measure what that angle is. So does anybody remember how many degrees are in a full circle? Real? 360. So there are 360s in a full circle. So when we break it up into our circle graph, every angle in there, if we add up all the angles, what's it going to equal? 360. Okay. If we were to count up the percentages, well, if we added up the percentages, what would they all equal? Will? 100%. If we added up all of the fractions, what would it equal? 1. Okay, 1 whole, if we added up all the fractions. So we're going to be using this in today's assignment. We're going to be interpreting a circle graph. You can make conclusions about the data in a circle graph. The largest section has the most data. The smallest section has the least. So if we had a 20% and then we have this whole half and this is 50%, a much bigger section is going to have more data. So maybe we have, this one's going to be labeled phone. Which one do you look at more, your TV or your phone? According to this graph, it would be the phone you look at more than the TV. Does that make sense? The bigger the section, the more it counts for. So making a circle graph using percents. So let's scroll up. The sections of a circle graph using percent. So the sections of a circle graph can be described mathematically using use a protractor to find the measure of an angle. To make a circle graph, you need to find the appropriate angle measure for each section. The sum of all the angle measures must equal 360. So, if we were going to be very precise, what tool would we use to make our circle graph? What do we call that, Brielle? That is not a protractor. That is what we need to use. What do we call it? Here. We have two different tools. Which one am I going to use to make a complete circle? This one, the compass. A compass, oh, friends, it's the teacher style. Because if I were to use a small compass here, it would be really small. I want to use a big. Except I can't fit my pen into this, so I'm just going to set it next to it. So to use the compass, you have a pencil in it, you have your center point, and you go around. So this is going to be hard because smart boards are a little bit trickier. So you hold the point down on your paper and you spin it around. It's too hard for me to do on a smart board, but when you spin it around, you get an exact circle. So if you hold your point on the paper and you spin your pencil around, you get the exact circle. So I am not going to be testing us on an exact circle. If you want to use a compass, if you have your compass, use that compass to make your exact circle. If you do not have a compass, you can freehand your circle like I just did, or I have compasses that you can use for this worksheet. But that's how we use the compass. Then, in the middle where you had put the points down, that's going to be your vertex. That's going to be where all the rays come out to make your angles. That's where the protractor comes in. Our protractor has our different percentages. It's half of a circle, so it goes half the degrees. So half of 360 degrees is 180. So you'll notice on the inside, we start at the right with the 0 and go all the way to 180 on the left. And on the outside, you start with the 0 on the left and you go 180 to the right. So it just depends on which way you want to draw as to if you're looking at your inside numbers or your outside numbers. Remember that if it's 20 degrees, it's not going to be a huge angle out of 180. So think it through. Am I looking at the right side, the inside or the outside? So let's look at our paper. Find the angle measure for each section. We have how many siblings in our table. How many siblings do people have? No siblings. 10% of the people surveyed had no siblings. One sibling was 40%. Two siblings was 25%. And 3 or more was 25%. If we add up all those percentages, what do we get? 100. 10 plus 40 is 50. Plus 25, 75. Plus 25 is another. It's 100%. So that's our full circle. So we need to make those angle measurements. So you can do this on your paper. If you need to borrow a compass from me, you can borrow a compass from up here, and you can draw your circle on your paper.
All right, these compasses.
If you're going to need a protractor, grab a protractor too. Quickly, grab and go, grab and go. quick.
I'm just gonna do it. What is this? Oh, it's so sharp.
Grab and go. If you need a protractor, grab a protractor also. Why do you think there's a sharp point?
To make sure that it keeps the.
Yeah, so it stays in that center and it doesn't move easily. So we need to be gentle with it.
Yeah. Where would I find it?
It's just in the school supply section, the office section.
It's so sharp. I tried.
Okay. All right, so draw your circle, and then we need to draw our angles. Our first angle is 10%, but on my protractor, it doesn't have a 10%. So how do I figure out what that angle is going to be? If I have a 10% and I need an angle, what should I do, Nick?
Don't you go to like the aim? Don't you go to the 10 on the protractor?
You do not go to the 10 on the protractor. 10% is not equivalent to 10 degrees because 10% is out of 100. Degrees is out of 360. So that was a good guess. But if I want 10% of 360, what does the word of mean, Brielle? Multiply. So I want to multiply 360 degrees by 10%. 10% as a decimal is 0.1. So 0.1 times 360 gives me 36 degrees. So in this exercise, you need to be able to convert your percentages to an angle measurement, to a degree. So you multiply the decimal of the percent by 360. Now we're going to use our protractor, and we want to draw an angle that's 360 degrees. So I'm going to put my protractor. This is hard for me to do on the smartboard. I'm going to put my protractor down, and I'm going to draw a line going straight across. I'm going to draw my first ray. Leave your protractor down, and I want, because I went to the right, that's where my 0 is. I need to count up on the inside to where 36 degrees is. I'm going to put a mark there where 36 degrees is, and then I'm going to use my straight line to go to the vertex. So this angle is 36 degrees. So if you want to draw a big circle, flip your paper over to the back side. So you're not drawing over all of the words. You can draw your circle on the back side, friends. So do we understand how to draw that angle of 36 degrees? Our next one is one sibling. One sibling is 40%, but I can't put a percent with a protractor. How do I find out what degrees 40% is? The same way I found out from 10%. What do I have to do, Brielle? Multiply that 40%, 0.40, by 360. When we multiply those two together, we get 114 degrees. So I'm going to use this ray as the bottom of my 114 degree angle. So I'm going to line up my protractor. Again, I'm pointing to the right, to the 0. So I'm going to count up on the inside all the way to 114 degrees. And I'm going to draw my straight line to that vertex. And this is 114 degrees. And that wasn't quite, it's hard because I can't put my protractor down on the smart board. So I was a little bit off there. 114 is more like to there. So the compass, you put your pencil up like that. So you have to hold your paper. Actually, I like to spin the paper. But you can't have stuff blocking it. So sometimes it's easier if you spin the paper because this compass kind of moves a little bit. So you can spin that paper to make your circle. Yep. Zoe.
Alright, so let me try again.
Okay, so you're gonna put this line here now,
Alright.
right? So that's your 0. You want to come all the way to 114. So that would be about right. We're gonna draw it straight.
William, why are you?
Go right there.
At first it looked kind of weird. I'm not lying.
And actually, as I'm looking at this, I'm thinking it out. Our next two, if we multiply 0.25 by 360, we get a 90 degree and a 90 degree. So my measuring it out with my protractor, I wasn't very exact with my measurements. Here's how I know this. Because 90 times 90 is 180. So 90 would be a right angle, is 90 degrees. So this is going to be 90 degrees. And my measurements are a little bit off here. So I wonder if my math was off in my multiplying. Yep. So here's where I went wrong. It's not 114. It's 144. I knew that something was wrong because when I added them all up, it didn't add up to 360. So that is a way to check your work. Do all of your degrees equal 360 if you add them all up? I was looking at my map and adding them up saying, this isn't right because I have this extra section here and I shouldn't. It should be 360 degrees. So if I go back and I recheck my math, I can see a mistake like this where it's not 114, it's 144. So that inside angle should look like this. So we have a straight line going across like this. The bottom is broken into half, 90 degrees and 90 degrees. We have 36 degrees and 144 degrees. So it's really important that you double check your work. Otherwise, your circle graph isn't going to be complete. I realized my mistake when I had a leftover section of my circle. So it's an easy way to double check to make sure you're doing your math correctly. So making a circle graph using the data. This time we have 8 people did aerobics, 22 did jogging, 6 did cycling, and 12 did weightlifting. So we need to find the angle measurements for each section. So we're going to make the circle graph. You would make it the same way, using your protractor, and then using the compass to make the circle, and then a protractor to find your measurements. But we need to find out what our measurements are. So if they're telling us there's 8 people that did aerobics, 22 did jogging, and 6 did cycling, and 12 did weightlifting, how do you think we can find the percentages? Think about what we just did. What 8 is what percent of what is our total number? How many people were there all together? We have 8, 22, 6, and 12. How many people is that? 8 plus 22 is 30. 30 plus 6 is 36. 36 plus 12 gives me 48. So there are 40 people all together. If I need to find 8 is what percent of 48, how do I find that? Who remembers? We just did this in our homework. How do I find 8 is what percent of 48? No, 1%. If my formula is the part equals the percent times the whole, I know my part is 8. I want to find the percent. My whole is 48. What math do I have to do? Riel? 8 divided by 48. So I'm going to divide both sides by 48. And 8 divided by 48 is 0.17. I'm rounding it, which would be 17%. So 8 people is 17%. Then you need to find the degree that 17% would be. So 360 times 0.17 would be 61 degrees. 22 divided by 48 is 0.46, or 46%. 360 times 0.46 is 167%. This would be 13%. This would be 47 degrees. This one would be 60 degrees. This would be 165. And that would be 45. So if I add up 60 plus 165 plus 45 plus 90, I get 360. And then you make your circle and you put those measurements on there. So the first thing you do is you have to convert from the number you're given to the degrees. So it's several steps you have to go through. You have to find the decimal, then you have to multiply it by 360 to get the degree. Then you can measure out your degrees on your circle. Does that make sense? Let's look at our workbook page for today. On our workbook page, the first couple of questions are just using the circle graph that they give you. Then we are going to be doing the front and back of this page. So page 119, 120. So it says display the data in a circle graph. So you need to draw your circle. Then we're given percentages. We need to find how to convert that percentage to a degree. So 30%, we have to multiply the decimal 0.3. So we're going to multiply 0.3 times what, Anthony? 360 degrees. So 360 times 0.3 gives me 108 degrees. So I'm going to go through and I'm going to find each of my degrees first, add them up, make sure they add up to 360, and then I'm going to put them in my circle graph. So 25% is 0.25 times 360, and I get 90 degrees. 40% is 0.4 times 360. I get 144 degrees. And then 5% is 0.05 times 360. And I get 18 degrees. So now I'm going to add all four of those up. 18 plus 144 plus 90 plus 108. And I get 360 degrees. Did we follow how I found my degrees? I take my percentage, turn it into a decimal, and I multiply it by 360. Gregory, do you know what to do for your homework? Okay, so you can pack up and head to the bus. So we can find our degrees, right? Once we know our degrees, we take our protractor. We line up I'm going to draw my first line. I line it up. 108, if I'm pointing to the right, let me do it so I can see my numbers. If I'm pointing to the right, I'm going to use the inside numbers. And I'm going to go all the way to 108, which would be about here, which would be here. And I'm going to connect it. That is 108 degrees. My next one is 90 degrees. I know that 90 degrees is going to be a straight line down because this is going to be a right angle. Then I have 144 and 18. So I'm going to look at this line. I'm going to go all the way around to 144. which is here. And then this last little section should be 18 degrees. It might not be exact, but look at, if I follow that line out, it's going to come right below that 20. So it is close. Okay. We might not be exact, and we don't have to be exact for this, but we want to be close. We know 18 degrees is going to be a whole lot smaller than 144 degrees. What you want to do then is label your sections. So where it's 108, you're going to label it walk. That 90 degrees was bike. 144 was bus. And 18 is with your parents. That's how you're getting to school. Does that make sense? Any questions? On the back side, you have to do one more circle graph. So we're doing a total of 1, 2, 3, 4, 5 circle graphs. Then this last one is just matching that percent with the angle measurement. So match, change it into a decimal, multiply it by 360, and find what degree it is. So that is your big thing with finding your circle graph, is being able to go from a percentage to a decimal, then multiply it by 360 to find your degree. With that, we're going to say goodbye to our friends at home and hope that you have a good day.